you can only read it during the day? I mean, you can't read it late, maybe whenever you're at lunch?
No,
or,
if it involves school,
Huh?
if it involves school, if he's not eating, he's not taking it home, because if he takes it home, it's not gonna get done.
Richard, I wrote down the numbers you fill them out.
Yeah.
It's not.
Oh, that's zero. The black is zero. There ain't no 10.
What, and
Zero
didn't do
through
them?
9.
No, I
Wait,
didn't.
what?
I put
0
them
through
all
9.
on.
There's not
Zero.
a 10. Yeah, it starts at 0. You got them numbered wrong. Okay, let's talk about this. And everybody is going to have to write down an answer when we ask this question. In both mass airflow and speed density systems, both air and fuel are calculated by what?
ECM?
No, I'm not talking about, I'm talking about the measurement, not the device. In both mass airflow and speed density systems, both air and fuel are calculated by blank. What's your best answer for that?
Barometric.
No, I got this written down.
The choices are going to be weight or volume. If that's what you think the answer is, write it down. Of course, if you get it wrong, you miss the question. So, by weight or volume.
I can't remember what I put.
Yeah, man, you read that thing. He read that thing from cover to cover, didn't you?
Yeah, like twice.
Yeah, was it good?
Wait, let me see, look at it. Let me look at it. I can't.
Did you
read in my
enjoy that?
head.
You don't have a test?
Oh, no, I already did it.
Yeah, he's already filled out the test. I think you turned it in, didn't you? Or did you?
I did.
Yeah. So he was on that thing. All right. Hang on here. I'm looking for something to put up here. That's amazing how stuff will hide from you when you do this. Okay. Now the next question. Explain the difference between long fuel trim and short fuel trim. Give me the best answer you can on that.
Short fuel trim compensates for the air or lack of air with fuel mixtures, and long-term short trim compensates after short trim is already compensated, but after over time.
All right. What are you thinking? I'm going to turn this on.
Was it wrong? Was it close enough?
You were sort of vague and foggy. How was I describing it? I was describing it
Like
yesterday.
teeter-totter.
Huh?
The teeter-totter.
Yeah, the teeter-totter.
I want to try Bison.
This is what I always like to, the way I like to describe this is, look here, you got,
Yeah.
watch this guys. This is a teeter-totter, right? This is a board, a teeter-totter, and you got two balls in the middle of that board, side by side. A big one and a little one. And over here, you got this guy sitting here, and his name is R. And on this side, you got a guy sitting here, and his name is L. Okay, so basically, L and R are constantly going back and forth trying to keep the board level. That's your oxygen sensor doing this. I gotta get a different marker. I've worn this one out. Okay, so short fuel trim is the guy, the little ball that rolls over this way whenever this one here starts to get a little bit too low. He rolls over this way a little bit and he fixes the balance, and this guy goes up and then this guy goes down, then he rolls back. So this little guy's always rolling back and forth right in here. You have everything like it's supposed to be, right? That's your little fuel trim man. Okay, and he's a little round ball, and like a Pac-Man or whatever. All right, now if there's too much of an out of balance situation that develops so that the board, this guy's way down here and this guy's way up here, this little fella, he starts rolling farther and farther and farther this way to try to fix that. If he hits the as far as he can go and it doesn't fix it, he calls for the big guy, which is long fuel trim, to roll over here with him and balance the load. Well, now when long fuel trim gets far enough over here where it gets balanced again, short fuel trim is going to go back over here. Long fuel trim is going to stay over here. Short fuel trim is going to be dancing around in the middle again. You got me? That makes sense? Now, both of these guys can go whichever way they need to keep that board level, but it's a constant roll. It's a constant roll back and forth, back and forth. Is that clear? Do you understand why I'm telling you that? So you'll understand long fuel trim and short fuel trim. That's the way I do it. Now, how does a vacuum leak, and I misspelled vacuum there, typically affect the fuel trims on a mass airflow system?
Makes it run lean. And it idles lean.
What do you think?
The speed density.
You guys have done enough with mass airflow to where you ought to know. What does a vacuum leak do? Even if you've got a leak between right now.
Run red.
Yeah, see that diagram on the board over there? See the diagram on the board? That is mass airflow. That is a mass airflow system. You know what I'm saying? That's a mass airflow system because you have, I drew this morning on paint, by the way. You know, give me a little applause if you think I did a good job. Woo! Woo! It's coming through the air cleaner. You're traveling through the manifold. Mass airflow sensor is looking at this air as it's coming through there. And actually, it's going to be a whole lot better about completely, you know, measuring all the air. It looks like some of it go past it, but basically, it's able to calculate how much air is going in there using this sensor, and it's got these wires that it's got wires going to the PCM. Okay, this is a throttle plate. Now, in this particular illustration, I've got the throttle plate wide open, and you got a TP sensor on there, and basically the air is going into the engine, which does its thing in there. This right here is telling this thing how fast you're applying the throttle. It tells it how much you're applying the throttle, where you're holding the throttle, if you're doing this with your foot like some people do when they drive. This goes through the engine right here, and there we go. And then we come out here, we got a couple of oxygen sensors here, we got a catalyst, we're going to the PCM, right? Okay, so while some of them have a mass airflow and MAP, what we're going to be talking like this time is we're going to be talking about some that have MAP and some that have mass airflow. This is the first thing that's got mass airflow on it. The next one is MAP. See the difference? The MAP sensor is connected to the manifold. Sometimes it'll be right on the manifold. Sometimes it's got a hose going to it. And it's basically measuring the same thing that mass airflow is. Basically, it wants to know what kind of air volume, weight, basically weight's what it's calculating, that we've got in there. So it's still coming through the air cleaner element. Mass airflow sensor is gone now. Goes in here. This reads, when you got a wide open throttle, do you have high vacuum or low vacuum? Vacuum and pressure are opposites of each other, right? If you got high pressure, you got low vacuum. If you got high vacuum, you got low pressure. If the throttle plate's closed, what's the vacuum? On a healthy engine, what's it supposed to be? Give me some numbers. Talking inches of mercury here. Anybody know? We've gone over this again and again and again and again and again. You know, 18 to 21. You wanted to be in the green on your little gauge, right? Remember that. Can you guys remember that? If I ask you that question, like in a verbal exam in my office in there during final exam time, are you going to be able to say 18 to 21, or are you just going to sit here with a bland, you know,
what was that,
double X look on
mercury?
your face and go, ooh, huh?
Is that for mercury? Is that
Inches of mercury.
Inches of mercury?
Inches of mercury.
What do you need the inches of mercury for?
That's your vacuum reading. 30 inches of mercury is all you can have.
Oh,
You know what I mean?
where do you find that at?
On the vacuum gauge.
Oh,
It's on the vacuum gauge, 18 to 21. That's inches of mercury.
oh.
You know, you gotta know what the scale is, you know. But anyway, or what the standard of measurement is. That's what that looks like. All right. Now let's get in here and look at your on your speed density system. Wait a minute. Take that back. How does a vacuum leak typically affect a speed density system? How does a vacuum leak typically affect a speed density system?
Idle engine high. Compensate for the leak.
Actually, it doesn't idle too high. It idles too high because even though the throttle plate may be closed, I'm going to put some more batteries in my laser. Even though the throttle plate may be closed, you got air coming from somewhere else, it's going to idle faster typically. Got it? I mean, you're right, but it's not idling fast on purpose to compensate.
Oh.
What does happen, if you remember that little sheet I gave you on your air intake deal, your air intake, your idle air control, whether it's the throttle plate being moved by a throttle plate motor, or whether it's an intake air, idle air control motor, whatever. Your idle air control motor, your throttle plate is supposed to be, when it's closed, and the idle air control's closed all the way up, it ought to be idle at about 550 RPM. And the target idle that the PCM is looking for, which would be 750 or whatever, is what the idle air control is gonna open up and let air go around the throttle plate, or the throttle plate's gonna move if it's one of those
And
kinds.
that's for the mass airflow, but in the speed density one, if the
No.
air is in there, it acts like it's an open throttle blade.
Yeah, if you've got like, on the other one, let me back up. Uh-oh, that's the wrong way. This one. See this? If we've got an air leak, like, I guess I'm gonna have to get a real pointer here. If we got an air leak anywhere between here and here, it's gonna be air that is not measured. Another word for measured is metered, right? And so the engine controller is making decisions based on what this is telling it, and this has to be tightly sealed so no air can come through there. And you're gonna also have a little closure hose for your PCV system going to this usually, because it can get clean air out of there. You know, you don't have to have a separate PCV filter. But the long and the short of it is, any leak in between here is gonna cause issues with your fuel trim and all that. Vacuum leak, which is gonna be downstream of this, is gonna cause fuel trims to change. On the MAP sensor, you're not likely to see fuel trims change because it's not measuring the incoming air, it's measuring the pressure in the manifold. That's right, that's all it's measuring. This is super important to understand, that's why I'm spending as much time on it as I am. So a speed density system will idle up a little bit, depending on the size of the leak, you know. On a speed density system, any data that's misreported by which sensors do you think are going to have a
MAP, TPS, IAC, O2, or oxygen, whichever you want to say. I know I'm missing, I think, one more.
ECT,
More.
engine coolant temperature?
Yeah.
That's how that's going to work. So you're basically going to have those vacuum leaks on a speed density system, and this is number 6, are not. Remember when I was talking about on the mass airflow? You got an unmetered air problem on MAP sensors. They're not, since it's not measuring airflow, you're not going to have an unmetered air issue on that one there. Okay, and after a while you get to where you'll know these answers. Positive numbers indicate what, while negative numbers indicate what when you're talking about fuel trim?
Positive is adding fuel, negative is removal of fuel.
That's right, and so you're correcting for a lean condition if you're adding fuel, you're correcting for a rich condition if you're removing fuel, okay? Okay, define, wait a minute, excuse me, what effect do dribbling or leaking injectors have on fuel trim? Now this is on either mass airflow or MAP.
Adding more fuel than is needed.
Huh?
Adding more fuel than is needed.
Yeah, there's actually fuel going in there, but the fuel trim's gonna do what?
Go negative.
Should it run lean?
Well, no, if it's leaking fuel in there, it's gonna be running rich. So what's your correction gonna be? If you're running rich, which way is the ball gonna roll on your teeter-totter? Right?
It's going to move to the
It's
lean.
gonna roll the other way. It's gonna roll in the opposite direction of the condition. If it's running rich, it's gonna try to drive it lean, to try to balance it back out.
What if it was like one of the injectors was leaking and it was like on one cylinder, then what the whole thing run with?
That bank would affect it. Nowadays you got an oxygen sensor on each bank, and if you've got one injector leaking, like on the right-hand bank, then that particular bank is gonna reflect a problem, but the other one will probably be 0. Got me?
What I was saying is like it'll make all the injectors on that side spray less fuel.
Yeah, I mean, it's gonna drive them all down. It's gonna reduce the pulse width on the injectors on that bank. And that's the way that's gonna go. Now then, define unmetered air. Not too hard if we saw what we saw up here.
Mhm.
All right, when unmetered air is present, fuel trims are unbalanced. Why will raising the engine speed from idle cause the fuel trims to trend back toward normal?
I'm not saying nothing. I've been answering everything. I'm still saying that it's actually just gonna, it's trying to level it itself out.
I know how you feel. I have to
RPM.
kind of sit on that, not say a lot whenever I'm in a class too. But
I want to say it's just trying to level out the RPM to keep that.
no, basically the amount of air that's leaking is proportionally smaller. If you got a little leak,
So you're just trying to get back to the ratio?
when you,
of
well, no,
9
what
to 1?
happens is when you get more air going in there, and you got a lot more air going in there, it's not even gonna notice a small leak, because you got such a small leak and you got so much of a volume of air, see?
So it's still trying to get the ratio of 9.
It's always gonna be getting the ratio that way, but the small leak's not gonna be noticeable if you got a huge amount of air in there, you see what I'm saying? Like if you got a waterfall, you're not gonna notice a couple of drops, or we're moving it. All right, now then, we're gonna talk about what he did here. This is a mass airflow system with a man-made exhaust restriction introduced. All right? So basically what he did here was he basically plugged up the, he had a way, I don't know how Alvin did this, but he had a way of making an exhaust restriction while he was running the engine to see what happened. Now, this is the thing, the Ranger had low power, and the only parameter identification that changed on the scan tool was the load pin. See, and what he was looking at is, when it's running like it's supposed to, what does everything look like on my scan tool? Now, watching the scan tool, see the red line right here? I'm gonna make an exhaust restriction, and I'm gonna see what happens when I do this. Alvin was a pretty sharp cookie when he did this. All right, so we're gonna take this thing, and the only thing that changed was the load pin, which is the engine load. And it should have been 95%, and it was only 74%. However, what we're getting at is, you may be looking at the scan tool, you may have a real problem. Now, you might, on this truck, Brian, that we worked on out there that you guys are popping that engine in because they had those camshaft issues, we absolutely were having a terrible time finding anything that we could use in our data stream because everything looked fairly normal. But we knew the truck had a problem. This is what we're talking about here. All right, now that one there, you see this right here? The MAP sensor, speed density with man-made exhaust restriction. This is a different system. The other one was mass airflow. This one here was MAP. All right, so this Envoy he was driving was struggling to stay at 60 miles an hour. He was doing everything he could. He got the pedal on the floor and all that. The data pins weren't showing anything out of the ordinary. In spite of the fact that he had an exhaust restriction, it was introduced right here. Where the red line is where he put the exhaust restriction in there. And see, he actually didn't have anything that you could point to on the scan tool that was showing anything driving down the road. You're more likely to pick it up in the service bay, but driving down the road, he saw nothing. And so that's why you have to have these other tools. Now what we did on that other one, we put this, we actually put these, check the pressure at the, in front of the manifold. And on that, you remember the one that we had, wasn't that an Envoy that you worked on, that we checked the pressure and put a catalyst on it, remember that?
Yeah.
That was an Envoy like this, and it had a legitimate exhaust restriction, but once again, our scan tool wasn't really helping us very much, right? Your scan tool doesn't always have all the answers. That's the whole point I'm trying to make. A lot of people feel like if I can plug a scan tool in, I've unlocked the mysteries of the universe. Okay, look at this one here now. A vacuum leak introduced in a mass airflow system. The red line is where you put the vacuum leak in there, right there. See that? Okay, so did you see what changed? Look at your long fuel trim, look at your short fuel trim. The short fuel trim, see how it was reacting a lot faster? As soon as he put a vacuum leak in, the short fuel trim started going up. The long fuel trim started going up too, but notice it waited a little bit. This is the big ball that's rolling up to the other end of the teeter-totter, and that's the little ball. The little ball goes up there quicker, and then it starts calling for the calf rope. It says, I can't fix this. You're going to have to come and help me. Of course, I hear those words a lot in here. I guess I'm the long fuel trim, whatever. All right, so here we got short fuel trim over here. We're basically looking at both sides of that. The red cursor shows where the vacuum leak was introduced, and the short fuel trim, long fuel trim, and O2 pins are reacting. Now, we're going to look at another set of scan tool patterns that's got speed density system. See that? And right over here, see how the red line's kind of over close to the left, and I really don't like that, but there's nothing I can do about the way those were captured. But the simple fact was, we got the vacuum leak introduced. Of course, he also let go of the throttle right there. See the TPS percentage? Now, well, I say that. This is actually, on this Envoy, it's got electronic throttle control. And it's idling. So he introduces a vacuum leak. And because the throttle position sensor is controlling the idle speed, as soon as we got a vacuum leak, the idle speed went up and the TPS went down. because the TPS said, I don't need as much idle speed as I got, I'm letting off some. So that was electronically done. This is not something he did with his foot, this was something he did in response to that vacuum leak. And there's your accelerator pedal position average. And then right here, we've got injector pulse width. See that? You can see what went on there, you know. Basically, it doesn't make near as much difference on that one as it did on this one. See that one right there, it made more of a difference across the board on the mass airflow than it did on that one right there. Of course, like I say, I wish the cursor was further over. Anyway, you get the point on that. Now, I'm gonna give you the answers to these other ones. The first one should be weight, W-E-I-G-H-T. All right, short fuel trim is representative of the current adjustments the engine controller is making, and like all the time. And the long fuel trim is a learned correction over a period of time. It only kicks in when short fuel trim can't handle it. Then here's something else I want to say right now that's pretty darn important. If you see long fuel trim numbers kind of high, you're probably going to see short fuel trim numbers right in the middle. So you can't look at short fuel trim numbers if you're looking at one that's just come into the shop and tell anything about it. But if you're looking at long fuel trim numbers that are way out of balance, and let's say that you take the battery cable off, you clean the throttle body, you fix the vacuum leak you found, or you replace the split air inlet tube and all that, whenever you put it all back together and you fire it up, as soon as it closes loop, you better start looking at that short fuel trim. If it starts climbing again, you ain't done. You got to fix something else if you're not through. That's what Verify the Repair is about. Vacuum leak on a MAF system drives the fuel trims positive. Makes, you know, it gets confused by that. That's number 3. Vacuum leak affects Texas speed density system. Doesn't usually change the fuel trim, but it'll change the idle speed. And then number 5 is MAF, TPS, oxygen sensor, engine coolant, and or IET. And then you've got your unmetered air would be 6, which is vacuum leaks on a speed density system are not unmetered air. Positive numbers indicate the addition of fuel. Negative numbers indicate removal of fuel. And then dribbling injectors would make the PCM go negative on the fuel trim. Air entering the engine has not been properly measured. That's what unmetered air is. And then when unmetered air is present, fuel trims are unbalanced. Raising the engine speed from idle will cause it to climb back to normal because the leak is a smaller one, and it's just not as big of a deal if you got an engine that's running really, you know, nice and fast. All right. Anybody got any questions or comments about that?